Alright, today we are looking at AB32 average value and fundamental theorem part 2. We're actually going to look at this in two parts video. Part 1 is right here, the average value, and part 2 is going to be fundamental theorem part 2, part 2, part 2, part 2. Lots of part 2s in there. So we're going to split this up into two videos. And mostly that's just for organizational sake, so you can have two separate videos for kind of each concept. That doesn't mean they're necessarily long. In fact, these are pretty straightforward ideas. So let's take a look at the first one. The average value of a function. So we have this function. Here's a curve. It's here, here, and then if I go to these next boxes, it's there and there as well. So this first picture that I'm looking at, if I were to make a box here, this blue box right there, that is, let's make that even thicker, that's, boom, blue box. That's an underestimate because we have all this extra area under the curve here, 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 here that's not even counted. On the other hand, we have, let's do a big red box. Here, this would be a gross overestimate here. So now we got all this extra area where we are counting this extra inside the box that's not even under the curve. So this is extra, extra, extra. But now if we kind of go in the middle between those two, we can get a box that's a little more appropriate. And even though we got a little bit out side of the box here, we also have a little bit extra on the inside. So those positives and negatives kind of balance each other out. A little bit in, a little bit out, a little bit over, a little bit under, kind of balances it. So the idea is we got this curve. It's curved. That's a general idea. But then within that curve, we're trying to change it into a box. So how do we take a curve that's shaded like this and turn it into a box? Well, let's notice a couple of things here. We got a width of the box. Let's bring down my pen, width. So we got a width of the box times the height. And those are really kind of represented by this distance here. Let's call this A to B. So what's the distance from A to B? That would be B minus A. And the height would be like F of C, where C is in the middle. So this distance here we're saying is B minus A, and this distance here is F of C. So it's just two numbers multiplied by each other, and that would equal the area of F of X from A to B. We want to make these two things equal. And that's really kind of the theorem that we're looking at. We call this the mean value or average value theorem for integrals. And the crazy thing is, you guys, it is incredibly related to the one for derivatives. They look different. They really do look different, but if you were to kind of do the same problem from two different things, the average rate and average value and things like that kind of actually go together pretty well. All right, so don't confuse them as the same thing, but they're very closely related. So something's happening here. We have that the integral would be equal to this thing. Remember, this was just the height times the width there. But if we divide both sides by b minus a, then we get this big fancy thing here. Is equals to f of c. And this right here, f of c, this is what we call the mean value or the average value. So if you're prompted to say find the average value, well, then you would do this. You would take the integral from a to b, but then you would divide by that distance. And that's kind of like what an average is. If you're thinking about just what is the average or the mean of a bunch of things, it's really the sum of a bunch of stuff, sum of things, divided by the number of things. So you take however many things you have, then divided by the number of the items that you have. So if you got like 3 test scores that you're trying to average, you add up the 3 test scores and you divide by 3. It's the same thing what we're doing here. So it makes sense. Kind of. Let's do it. Okay, so let's just jump right into it. We have a function. Here's f of x. So we want to take the integral over an interval. And this integral is going to be of x squared plus 1. And it's from 0 to 2. But we want to divide that answer. So we're going to figure out what that answer is. And we're going to divide it by that distance from 0 to 2, which we could say is 2 minus 0. Now if I were to simplify this, this is the same thing as saying 1/2. I can pull this denominator 2 out to the front. It'd be 1/2 times the integral from 0 to 2 of x squared plus 1 dx, of course. Okay, so let's calculate this value. It's a simple power rule. We got x squared becomes x cubed over 3. And then the plus 1 is plus x. We're going to evaluate that from 0 to 2. But then we're going to take that whole thing, and we're going to divide it by 2 or multiply it by 1/2. So let's see, we plug in the 2. Notice that when we plug in the 0, this is kind of interesting. These two terms here are just x. There's no constants, which means when I plug in 0, those two terms are going to be 0. So really when I'm doing my top minus my bottom, for the tops we're going to have 2 cubed minus 3 plus 2. And on the bottom we'll have 0 cubed over 3 plus 0. So it's just 0, 0, 0, 0, lots of zeros. And we're going to multiply that whole thing by 1/2. So 2 cubed over 3, that's 8/3, plus 2 is really 6/3. But then we're going to multiply that by 1/2. Keep on working our way here. And 8/3 plus 6/3, that gives us 14/3 times 1/2 is really 14 over 6, or even more simply, 7 over 3. Okay, so this is our average value. So if we're thinking about that curve, x squared plus 1, which in this case would look like between 0 and 2, it would look kind of like this. So we're talking about this average value here, this f of c, is 7/3. But then the other question is, what's this value here? And that's what we're about to answer here. What is this c that's in the middle? So we got to figure out, when do those two things intersect? When does the function x squared plus 1, which is this curve, x squared plus 1, when does it intersect the value 7/3? That's just an equation. You set them equal, just like this. Alright, so let's calculate it. X squared plus 1 equals 7/3. Well, I got to subtract 1 from both sides. That really means subtract 3/3 from this side. So we'll have x squared equals 4/3. Then we got to take the square root of both sides. And on top, square root of 4 is 2. On bottom, we got square root of 3. And that's fine to leave it like that. Of course, we got some old fuddy-duddies writing the AP test who still rationalize the denominator, even though we don't use slide rules anymore, and that's the only reason you would need to, because we have calculators. But they would do this. So then you have 2 square root 3 over 3. Boom! Actually, c equals that. Done. That was not hard at all. Not at all. I really suggest, before going on to the next example, rewinding and watching the same example again, just to kind of see where all the numbers came from. Because it's really simple, but it's almost so fast, so easy, that it passes you by. So let's do another example here. Ooh, we got sine of x. Trig. Let's do it. So this means that I'm going to have the integral from 0 to pi of sine of x dx. But we're going to divide it by that interval from pi minus 0. So let's see what we get. The antiderivative of sine of x is really negative cosine of x. We're going to be calculating that from 0 to pi. And then we're going to be dividing that by pi as well. Okay, so the calculation here for this numerator in the fraction is going to be negative cosine of pi minus negative cosine of 0 all divided by pi. Well, let's see what we got. Cosine of pi is negative 1, so that's negative negative 1, or just positive 1. Then we got minus minus, and then this cosine of 0 is 1 all over pi. And if we were to simplify that, that gives us 2 over pi. So there's my average value. Cool, cool, cool. Now let's take a look then. What's that value c? So again, we have this curve sine of x. We're going from 0 to pi, and if you think from 0 to pi for sine of x, that means that we have a curve that kind of looks like this. So we're looking for a box that kind of encloses that area. So this top piece here, this is 2 over pi, about 2/3-ish. But the crazy thing then is, where is this point in the middle where we equal that curve from 0 to pi? Because this is what sine of x looks there. And we're going to get two possible answers here. Take note of this, here and here. So either one of those would work. And that's kind of weird to get more than one answer. This could be C or this could be C. Either one. Just because of the shape of the graph. That's kind of the way that this one works out. Well, let's see what we got. So our average value, we need to set our average value equal to our function and then solve. When our average value happens to be 2 over pi and our function equals sine of x. Now this is where it gets a little bit crazy, because you're looking at this and there's no easy algebraic way to do this. So as I'm looking at it, I'm going to just have to use a calculator. I'm going to have to do arc sine of both sides and arc sine of 2 over pi. I'm going to have to set that's going to be equal to arc sine of x, and arc sine of sine cancel each other out, and that's just x. So what's arc sine of 2 over pi? Well, I could just leave that. That's technically a number, and I'm done. But I can use my calculator to actually calculate that. So that's the same thing as doing the sine inverse, second sine. And our number in here is 2 divided by, then we got pi. We type that in, let's see what we get. So this is our answer in radians. And let's double check my mode. We are in radians. Perfect. So the answer would be x equals, well, I lost it there for a second, 0.6901. 0.6901. Boom. Done. That was almost too easy. Yeah, I think it was too easy. Are we already done with part 1? I think we are. Let's just double check. Yeah, we are. So that's it for part 1. This was a nice short video. We're happy about that. Yay! Check it off your list, happy stars, and join me in part 2. This is an easy thing, so be careful. Watch it a couple times if it takes. Don't just race through it and say, oh, I don't get it. Well, then watch it again.